How does a building only weeks old nearly declare itself unsafe? Christmas Eve 2018. Residents of a brand new luxury tower in Sydney hear a bang like gunfire and are ordered into the street. Opal Tower had been open barely 4 months and it was already cracking. This is the story of what failed inside that $31 million building, who was blamed, and how one flawed concrete panel triggered a national crisis over whether any new apartment in Australia could be trusted. Opal Tower was designed to be a modern centerpiece in Sydney Olympic Park. Completed in August 2018 at a development cost of roughly $128 million, the 36-story residential high-rise contained 392 luxury apartments. The project developer, eCove, marketed the building as a premier residential destination, featuring a design by the architecture firm Bates Smart. To execute the build, eCove appointed Icon Construction, a major contractor responsible for translating the complex concrete and steel design into a vertical community. When the first residents moved in, the tower represented a commercial triumph. Buyers paid premium prices for what they believed was a state-of-the-art home, trusting the high-profile names behind its construction. The handover went smoothly, adding a new landmark to Sydney's growing residential skyline. At approximately 3 p.m. on Christmas Eve 2018, the quiet holiday routine inside Opal Tower shattered. Residents on level 10 heard a sudden violent bang, a sound described by those inside as a massive snap echoing through the concrete walls. Within minutes, emergency alarms wailed, and police and fire crews rushed to the scene. Authorities established an immediate exclusion zone, ordering 3,000 occupants from the tower and surrounding buildings out into the street. Families preparing for Christmas dinner were forced to abandon their homes with almost no warning, carrying only what they could grab. By midnight, inspectors declared 51 apartments structurally unsafe, leaving dozens of families stranded in temporary emergency housing at the nearby Sydney Showground. A building completed only 4 months earlier was suddenly a restricted zone. The immediate panic quickly gave way to a deeper, more troubling set of questions. What structural component had failed inside this brand new luxury high-rise? Why did a premier residential tower suffer such a catastrophic rupture? And why would this single cracked wall eventually trigger a massive reckoning across the entire Australian construction industry? The danger was not confined to a single concrete wall on level 10. Within hours of the structural failure, emergency officials realized that if the structural elements shifted further, the physical consequences would spread well past the building's footprint. The initial 250-meter exclusion zone was quickly expanded. Authorities treated the damaged slab as an active threat to the surrounding public space, shutting down nearby streets and clearing adjacent apartment blocks. On December 27th, the structural movement continued. Engineers tracking the cracked level 10 panel detected additional displacement in the concrete, proving the initial safety clearance had been premature. Authorities ordered a second full evacuation of the tower, forcing families who had just returned back onto the streets. This second displacement pushed the crisis directly into the new year. To protect the public and safeguard transit infrastructure, emergency services widened the exclusion perimeter to a full 1-kilometer radius. Rail lines and roads near Sydney Olympic Park were closed, and thousands of residents from the tower and neighboring complexes found themselves barred from their homes. The holiday precinct became a silent zone, monitored by laser sensors designed to catch the slightest structural shift. What had started as a crack in a single apartment wall had escalated into a full-scale civic emergency, paralyzing a major metropolitan precinct. Opal Tower's structural frame relies on a sequence of heavy precast concrete facade panels designed to transfer the immense weight of the building downward, floor by floor. At each level, these vertical panels do not rest directly on the flat concrete floor slabs. Instead, they sit on specialized horizontal support elements known as hob beams. A hob beam is a raised concrete ledge that acts as a bridge. Its primary function is to collect the weight from the wall panel above and distribute that load evenly across the building's main structural floor slab below. In a standard design, this load transfer system operates seamlessly, spreading thousands of tons of vertical pressure over a wide, uniform area. But on level 10, the weight did not distribute evenly. When the precast panel was installed onto the hob beam, the connection between them was flawed. Instead of a solid, continuous bed of high-strength grout filling the entire joint, grout was only placed along a portion of the bearing gap. This partial grouting left empty pockets, creating an uneven and highly eccentric bearing point. To verify this mechanism, independent investigators later performed finite element method analyses, mapping the exact stress distribution across the connection. The resulting models confirmed that when the grout coverage was reduced to just 40% of the design specifications, the localized compression pushed the stresses inside the hob beam 25% beyond its physical burst capacity. This offset concentration of weight meant the load compressed onto a narrow, offset edge, generating unexpected bending forces and extreme bursting tension inside the concrete. The concrete itself lacked the capacity to resist this intense focal point of pressure. Laboratory tests of concrete cores extracted from the damaged areas later revealed that the concrete in these zones had a compressive strength of only 22 to 24 megapascals, well below the 30 megapascals specified in the structural design. Compounding this material deficiency, the internal steel reinforcement within the hob beams fell short of the minimum requirements set by national standards. The design did not provide adequate steel to counter the bursting forces, and the actual bars installed on level 10 were 20mm rebars instead of the 28mm bars required to handle the design load. Under the crushing downforce of the 36-story tower, the under-reinforced lower-strength concrete of the hob beam reached its limit. The beam literally burst under the pressure. The sudden failure of this single support element caused the adjacent precast concrete panel to crack and split, transmitting stress patterns directly into the surrounding floor plates. A surface crack in a plaster wall is cosmetic, but a structural fracture in a primary load-bearing panel and beam connection alters the path of gravity throughout the vertical column. When one primary load-bearing joint fails, the weight must find alternative paths, overloading neighboring elements and turning a localized defect into a systemic risk that threatens the stability of the entire building. On February 19, 2019, the independent engineering panel led by UniSearch delivered the Opal Tower investigation final report to the New South Wales Minister for Planning and Housing. This document stripped away the speculation, replacing structural theories with documented institutional findings. The expert panel concluded that construction and material deficiencies directly precipitated the failure. The most damning evidence lay in the material testing. While the structural design demanded concrete capable of resisting 30 megapascals of pressure, laboratory compression tests of cores extracted from level 4A revealed actual strengths of just 21 megapascals. The builder had poured substandard concrete into primary load-bearing zones, leaving the structural system fundamentally compromised from the day it was built. With the release of these official findings, the mystery of the Christmas Eve evacuation ended, and a massive battle over accountability began. The technical question of what physical forces cracked the tower was now resolved. In its place, a far more contentious question arose. Who allowed these defects to occur, and who would pay to fix them? The official wording of the government report became the baseline for all subsequent legal actions, shifting the focus from an engineering failure to a systemic collapse of oversight. The structural failure on level 10 was only the opening chapter of a much larger crisis. As independent inspectors and forensic engineers began a full audit of the entire tower, they uncovered a widespread pattern of substandard workmanship. By early 2020, these follow-up inspections exposed more than 500 additional defects scattered throughout the building. These findings confirmed that the tower's problems extended far beyond a few cracked concrete supports. Inspectors documented water leaking through the facade, non-compliant fire safety barriers inside the utility shafts, and widespread failures throughout the mechanical and hydraulic systems. For the residents, the financial toll of these discoveries arrived immediately. The building's insurance premium skyrocketed, jumping from $100,000 in 2018 to over $1 million by 2020. This massive increase forced the Owners Corporation to consider special levies just to keep the building insured. The Owners Corporation, led by Chairman Shady Eskander, realized the physical damage of the cracked beams was matched by an existential financial threat that threatened to wipe out their life savings. In June 2020, the owners took action, launching a massive class action lawsuit in the New South Wales Supreme Court. The legal claim targeted the builder, Icon, but it did not stop there. Because the land was owned by the Sydney Olympic Park Authority, the lawsuit dragged the New South Wales government directly into the center of the dispute. Owners demanded compensation for the skyrocketing insurance premiums, the loss of property value, and the mounting costs of rectifying the hundreds of newly discovered defects. What had begun as a localized engineering emergency on Christmas Eve had officially transformed into a high-stakes legal war. The luxury high-rise became a contested courtroom battleground over corporate and state accountability. While lawyers fought in court, the immediate priority on the ground remained the physical stability of the tower. Icon launched a massive $31 million remediation program designed to salvage the building's structural integrity. The engineering solution was invasive. Workers had to install heavy steel plates and post-tensioning systems to reinforce the compromised hob beams, essentially retrofitting a skeleton inside the concrete frame. They stripped away damaged precast panels on the worst affected levels and replaced them with higher-strength concrete units. Grouting crews injected high-strength mixtures to fill the gaps that had caused the initial failure, while additional teams undertook extensive waterproofing and fire safety repairs. For the residents, this engineering campaign disrupted every aspect of daily life. Hundreds of families spent nearly a year living out of suitcases, scattered across temporary rentals, hotels, and serviced apartments near Sydney Olympic Park. The developer and builder covered millions of dollars in relocation and accommodation fees, but no amount of funding could replace the stability of a permanent home. Month after month, displaced owners watched the remediation progress from behind safety barriers. The return occurred in slow, quiet phases. It was not until late December 2019, almost exactly 12 months after the sudden Christmas Eve evacuation, that authorities cleared the majority of residents to move their belongings back into the tower. Even then, the homecoming felt compromised. A small number of apartments remained vacant well into the following year as workers finished lingering repairs on the facade. This $31 million fix restored the physical strength of the concrete, but it could not erase the psychological toll of the past year. The enormous price tag of the repairs served as a stark lesson in modern construction. A single engineering shortcut, a few missing millimeters of steel, and a deficient concrete pour can ultimately cost millions to correct. The physical cracks were patched, but the sense of security that buyers expected when purchasing their luxury apartments was permanently gone. On June 14, 2019, while Opal Tower residents were still displaced, a second structural emergency shattered any remaining confidence in Sydney's high-rise market. Authorities ordered the immediate evacuation of Mascot Towers, a 10-year-old development in the city's inner south. More than 1,000 residents in the 131-unit complex packed their lives into suitcases before a strict evening deadline, fleeing after engineers discovered severe cracking in primary basement support slabs. This structural movement was later linked to soil-filled water pumped out during construction at an adjacent development. Many owners faced immediate ruin, forced to service mortgages on homes they could no longer legally enter. The Mascot crisis proved that Opal Tower's defects were part of a far larger epidemic. Public fear shifted from a single defective address to a systemic pattern of bad building practices. Independent economic modeling by Equity Economics and reports from the CFMEU soon revealed the staggering scale of this issue, estimating the total cost to repair serious defects in New South Wales apartments at $6 billion to $6.2 billion. What began as a localized emergency on Christmas Eve had expanded into a multi-billion-dollar statewide housing crisis, leaving thousands of apartment buyers realizing their luxury investments were massive financial liabilities. The structural failures at Opal Tower exposed systemic gaps in how Australia certified high-rise developments. Private certifiers hired directly by developers had routinely signed off on buildings with minimal government oversight. This conflict of interest prompted the New South Wales Parliament to pass the Design and Building Practitioners Act 2020. Effective from July 2021, the legislation introduced a non-delegable duty of care, forcing builders, designers, and manufacturers to take legal responsibility for structural failures. It also established a mandatory registration system for engineers and architects, but legislative changes could not immediately repair the damage to public trust. A Deakin University survey revealed that 97% of new apartment buildings in the state had at least one defect. Fearing financial ruin, buyers walked away, causing sales of new apartments in New South Wales to plunge by 75% in the months following the crisis. What began as a fractured concrete beam on level 10 had permanently shaken the economic foundations of the housing market. A 117-meter concrete tower depends entirely on the integrity of its smallest connections. When a single support beam is poured with low-strength concrete or a joint is only partially filled with grout, the entire vertical path of gravity is disrupted. The failure on level 10 proved that, in modern high-rise construction, an isolated defect does not exist. One compromised element places every floor at risk. This physical reality turns a localized engineering error into a broad crisis of faith. leaving apartment buyers to wonder if the buildings they call home are actually safe. Today, the physical cracks are patched, but structural trust remains shattered. As vertical cities rise, we face a sobering reality. A home must be a sanctuary, not a high-stakes gamble. Until accountability replaces compromise, the true cost of our skyline remains unacceptably high. How do we rebuild trust in our buildings? Share your thoughts below.